Okay, this is page 181, section 3.5, Algebra 1. It's transformations of linear functions. Guys, we're going to, I don't particularly enjoy this sometimes because it actually hurts you sometimes in graphing lines. However, it does help you when we graph parabolas in the future. So that's why we do it, is to kind of give you an estimate. But what we're going to remind ourselves is that we have graphed using this, correct? We're going to look at a different version of this today. The nice thing is you don't have to memorize the version today, but you do have to recognize when you compress and stretch and things like that. But this is called slope-intercept, right? Okay, I go over it a lot, don't I? This is where we touch the y-axis. This is our slope, correct? Slope is rise over run. All right, we good with that? Okay, so today we're going to play with this a little bit. We're going to put a number out in front of x. We're still going to call it, it's still going to be m. We're going to change it to a. And then we're going to put a number in front of x. And then we're going to have an h and a k. Now you might say, what is all of this stuff? Okay, well, I'm going to show you how we can compress and stretch and turn and all these based on this. Now the reason I chose this is because we have this equation quite often. Now, remember I said a replaces m, doesn't it? Okay, and k replaces b. This is k. My k's stink. And then we added a new number in c, and c is going to have an effect on everything also. All right? Now, you do not have to memorize this. All you got to do is know how to recognize what it does to the graph. Okay? All right. Well, speaking of graph, we're going to talk about a parent graph today. What's a parent graph? A parent graph is a graph in which we can transform. Okay? And the graph that we're going to transform today is y equals x. That's our parent graph. That's our parent graph, y equals x. Now, if you want to write it out, it's y equals 1x plus 0. Is that correct? All right. So what it looks like is, people, it has a y-intercept of 0, and it has a slope of what? 1. So it's 1 up, 1 over. 1 up, 1 over. So it looks like this. That's your parent graph we're going to talk about today. All right? Now what we're going to do to it is we're going to stretch it. We're going to compress it. We're going to turn it. We're going to flip it. We're going to do all kinds of transformations to it today. All right? So let's take a look at this. On this is what it looks like on the graph. And I'm going to put it in black, and then we're going to do others around it. Okay? But let me show you what it looks like with the coordinate plane. This is our parent graph. Right here. See what it looks like? That's our parent graph. Any questions? Okay, I'll bring it back in a minute. All right? So, remember that I'm going to erase this. This is our parent graph, y equals x. All right, the first thing I'm going to do is I'm going to add a number outside of it. So I'm going to go y equals, remember this formula right here? I'm going to go y equals x plus 2. Okay, now from yesterday, or from not yesterday, well actually last week, you should know what this does if we add a 2 to it. Okay, what it does to the parent graph is when we add a k, this is what I'm talking about, this k right here. Right here. What we're going to do is we're going to raise it up 2. All right? So, see this graph right here? We're going to raise this up 2. We're going to move the whole thing up 2. So, see the origin? Goes up 2. All right? And it looks like this. Has the same slope, 1 over 1 up, right? Looks like this. Now, let me ask you a question. This is what it looks like. This is what it is. Okay? If I change this to plus 3, what does it do to the parent graph? It moves it up 3. All right? It moves it up 3. What if I subtract 2? What does it do? It moves it down. So this guy on the outside moves it up and down. All right? You understand that? So what we say is this is translated up 2 units. Would you please write that? Translated up 2 units. All right? Okay, so let's play. What if I did this? Y equals x minus 7. What would happen? It's translated. What does translated mean? Translated means a slide down 7 units. Tyra, do you understand that? Okay. Now, what would happen if I wanted to move it left and right? Okay, left and right is the H. Okay, here's the weird thing. I'm going to show you. Y equals, all I got to do is put an x plus 2. All right, now here's the weird thing, guys. You think this moves it to the right. It doesn't. It moves it to the left. I'm going to show you. See this graph right here? I'm going to move it to the left 2. 1, 2. So it actually ends up being the same, doesn't it? So this green line, because it has the same slope, let's change it so it's not on the same line. Let's change this to x minus 2. This is going to translated to right. I'm going to keep it the same. So translated right 2. It looks like it should be left, doesn't it? Yes, Jackson.
So
if I put it in parentheses, Jackson, if I put the number in parentheses, right, with the x, it moves it to the right 2. So it looks like this, Jackson. So it looks like this. You understand? Yes, sir.
yeah, so if you have x, like x minus 7, you can't change these to plus and negative.
No, it would be, did you hear what Jackson said? Be careful. If you do this, if you want to do x minus 7, you can, but understand that it moves it, translated, right 7. You see what I'm saying? And that throws you off, doesn't it?
Yeah.
I would leave it like this. Translated right 7. Now how do I move it left? What's that? All right, x plus 7 is translated, it's backwards, isn't it? Translated left 7. Okay, Braxton, so I got to remember that if a number's on the outside, right, it's normal. Correct? But if I put parentheses around it, it switches. This is moved 7 to the right, this is moved 7 to the left. So if the number is in parentheses, I'm moving left and right. If the number's outside the parentheses, I'm moving up and down. You got it? Okay. Now I want to change this A, right? What happens is, when I go y equals 3x, all right? This number right here is called A. A is greater than 1, okay? A is greater than 1. Stay with me. What's going to happen is, this line's going to go up faster. It's going to go up faster. So this is what we call stretched vertically. What's vertically mean? What's that? Up and down. Stretched vertically. All right? So, what we have is, if we're going to go 3x, it's going to go up faster. My slope is 3, so I still go through 0. I'm going to go 1, 2, 3, 1. So it's going to be right here. It's going to be this line right here. 1, 2, 3, 1. And it looks like this. Look what happens. Look what happened. It stretches it as we pull it. This is what I mean stretched vertically. Stretched vertically. All right? Now, what's really weird is, what if I change this to 1/3? I go y equals 1/3 x. A is less than 1, right? Do you understand that? It's less than 1. If this happens, okay, we're compressed vertically. We're compressed vertically, which means, guys, I'm going to try to use a different color here. Compressed vertically, it means that I still go through 0, 0. It's just my rise is 1 and then 1/3. So it looks like this. Do you know what compressed means? Compressed means I push down on it. So I'm pressing it down. Do you see what I'm saying? All right, we good?
That's kind of confusing.
I know it is. That's why I'm talking to you about it. All right? So if the number's bigger than 1, it actually goes up faster, right? I'm going to erase some of these, okay? Because it's getting wild, isn't it? Why do I leave the black one? All right, it's the original. It's called the parent graph. Parent graph. All right. Okay. You got all these? We good? All right. Now, you remember how we went into parentheses and it translated left and right? When outside the parentheses, it was up and down, right? Right? Now we're going inside the parentheses with those numbers. So we're going to go y equals parentheses 3x, where c is greater than 1. Remember, we changed the letter to c, right, on the inside. C is greater than 1. All right? This is, be careful here, watch this, compressed horizontally. It's compressed horizontally. Now, take a look at this. Did everybody write that down? This is what it means. Compressed horizontally is we're going to push in like this. When we push in like that, it pushes it up. So compressed horizontally and stretched vertically look the same. Do you understand that? Because if we push this way, it's like stretching this way. If we push this way, it's like stretching this way. You understand that? Okay, you're going to have to know all these. So what happens then when we put the 1/3 inside, do you think? Where c is less than 1. It is stretched horizontally. So if it's in parentheses, it's a horizontal. So stretched horizontally, guys, stretched horizontally means that we pull this way, which means that it flattens it out. So stretched horizontally and compressed vertically are the same thing. Do you get that? Do you get that? Give me a yes, something. You okay with that? All right. So let me go through this again. If we have a number on the outside and we're adding it, we're moving it up. Okay? If we have a number on the outside of the parentheses and it's negative, we're moving it down, right? Right? Okay. If we have inside the parentheses, it's the opposite. If we have subtract a number, it's translated right, and if we have a plus, it's translated left. Okay, so those are all translations. These are all slides. Do you understand that? Okay. Now, if we start putting a number times the x on the outside of the parentheses, Jackson, we have stretched vertically if that number is bigger than 1. If that number is less than 1, we have compressed vertically, so we're pushing down. Okay? If we have a number on the inside that is larger than 1, it's compressed horizontally, so we're doing this, which is stretching vertically. And then if we have a fraction on the inside, we're stretching it horizontally, which is compressing it vertically. You understand what I'm saying? All right, we have 2 left. Thank goodness, right? Okay, we're still working with the parent graph. We're still working with the parent graph, okay? We're still working with y equals x. All right, now what are we going to do to it now? I'm going to make a, remember, I'm going to write this out again so you know. It's cx minus h plus k, right? All right, so I'm going to look at this number right here. Right? This number right here. And if this number, if a is less than 0, that means it's negative, right? A is negative. It switches the points. So you see this right here? It makes these negative and it makes these negative. So what happens is you get this. This is called a reflection. A reflection. If this number is negative. Okay? All right. Now, here's the weird thing. What if the c is negative? So you have y equals a negative. Okay, let me write an example, the first one. This could be y equals a negative 2x. Do you understand that? But y equals, what if we put the negative on the inside also? This also reflects. Here's the weird thing, guys. Remember this graph that I showed you? On the first one, we reflected these points up here and these points down here. On this one, we're reflecting these points across here and these points across here. So it looks like the same graph. These two look like the same graph. We're just reflecting them different ways. Isn't that weird? Okay, so you need to know that. All right? All right, so what I'm going to do is I'm going to give you, I'm going to give you a problem, and you're going to tell me what's happening to the graph, the original parent graph. So I'm going to write it out, and you're going to tell me what's happening. All right, you ready? Okay, so number one, all right, let's do this. G of x equals, I'm going to use, instead of y, I'm using a fancy way to write a function. Is that okay? G of x equals a negative 2x plus 4. Okay. All right. Now, you got to remember some things, don't you? Throw this, I don't know if I can get this in here. Nope, I can't. All right. So, what does this mean? All right. And I forgot to write the reflections down, guys. I apologize. This one is reflected across the x-axis.
Mr. Ellis,
Yes.
can you let the wrestlers go, please?
Yes. Would you finish watching this, guys? Okay. The assignment is page 186. Page 186. Thank you, Ashley. 12 through 36. I didn't think you guys were leaving until 10.
Me either.
That's what I was told. Okay.
36 all.
Yes. And this one is reflected across the y-axis. All right, ready? So let's take a look at this. Anybody want to tell me anything about this graph? What about the +4 out here? Tyra? It's what? No. Think about what we talked about today. Braxton?
Translated up 2 units.
All right, it's translated up 4 units. Do you get that, Tyra?
4 units.
Tyra?
Yeah.
All right, well, what about this -2 in front? Ashley?
It would be to the right.
I'm gonna have to cut it short. It's reflected across which axis?
X.
The x-axis. Do you understand that? You understand that? Good luck, guys. I apologize. I thought you weren't leaving till 10.
I'll watch the video.
Okay, does that make sense to you? Yes, no, maybe? All right, let's take a look at this one. H of x equals 0. The nice thing is you can go back and look at your notes on these. X plus 1, all right? Okay. What about this guy? Be careful here. What about the inside of parentheses? What do you think? It's going left, so it's called translated. Tater, do you understand that?
Yep.
Translated left, 1 unit. Okay, what about this 0.5? That's less than 1, isn't it? Okay, so let's take a look here. And it's on the outside of the parentheses, right? So it's less than 1. It's 1/3 is less than 1, right? So it is compressed vertically. Are you understanding this, Charlie? Good, we're going to come back to you then. Compressed vertically. All right, you ready? Charlie? Here we go. G of x equals parentheses 4.1x minus 2. Okay, let's start with the minus 2. That seems to be the quickest, Charlie. What would that be? Okay, translated down. How many? 2 units. Very good, Charlie. Okay, now I'll switch to somebody else. Tirsa, 4.1x. It's inside the parentheses, and it's bigger than 1. It's inside the parentheses, so it's, I think it is this one. I think you could be right. It's greater than 1, right? So it's compressed horizontally. Does that make sense to you? Okay. So this is what you write. So there's no graphing. It's just reading the graph, isn't it? Okay? Any questions about that? All right. Turn to the exercises. I'm going to shut this off.